Hello everyone, welcome to all of you on my YouTube channel. So here in this session, I am going to discuss today about the heterogeneous reaction system. And already I have discussed about the non-ideal reactor system having different parameters like one parameter model, two parameter model, and two parameter model. Already I have discussed about the dispersion model as well as the tangle series model also. Okay, so here in this session today I'm moving forward in chemically exchanging topics, and this topic I will be demonstrating about the heterogeneous reaction system, how the in heterogeneous reaction system how diffusion will play an important role. I will be talking about the concept regarding efficiency and all. So let's try to understand how we'll start this particular topics. Okay, so. First of all, my dear student, when we talk about the heterogeneous reaction system, heterogeneous reaction system. So, when we recap about the homogeneous reaction system, my dear student, in homogeneous reaction system, what happens over here? All the reactant, product, and catalyst used to be in the same phase. Okay, reactant, product, and the catalyst used to be in the same phase, then it will be called as the homogeneous reaction system. But here, when it comes to the heterogeneous reaction system, my dear student, the definition is not going to ask in your GATE examination, but the definition becomes very important when it comes to the interview. So they talk about how can you define the heterogeneous reaction system. So in a heterogeneous reaction system, my dear student, the reactant, product, and catalyst, I'm assuming, either of any, at least one of them used to be in the different phase. Okay, at least one of them used to be in different phase, then you will call it as a heterogeneous reaction system. Are you getting? So I think the definition is very clear to all of you. Okay. Just like my dear student, when we talk about the reaction of nitrogen plus hydrogen and getting converted into ammonia and H3. So here we will be using iron or molybdenum as a catalyst. Okay, so here nitrogen is work as in used as gaseous state, hydrogen is used in gaseous state, and NH3 is also used in gaseous state. But here solid iron catalyst is used or molybdenum used. Okay, so due to this particular reason, this reaction will be called as the heterogeneous catalytic reaction. Are you getting? So these things that you should keep in your mind, at least one of the components should be in the gas, different phases, then it will be called as the heterogeneous reaction system. Okay, so medicine sometimes in mark examination you may see these types of questions because the easiest question that work can make for you people, like on the basis of the definition. Okay, so yeah, just try to understand definition. Questions can be made on the basis of definition also, it becomes very important. So now when we talk about my dear student heterogeneous reaction system, there are different types of rate of reaction that you need to define here. And so first rate of reaction that I'm going to define is solid gas catalytic reaction here. So solid gas catalytic reaction. Okay. So here, my dear student, generally what we define rate of reaction, that is equals to my dear student minus 1 upon V, and this is as simple dNA by dt. So here it is the it is a homogeneous rate. Generally, in a homogeneous reaction system, we used to write in this way. Are you getting? This is homogeneous reaction system. I'm trying to connect these things to the heterogeneous, so it will be very easy to understand the thing. So, my dear friend, so in heterogeneous reaction system, what happens, the rate of reactions, can be defined in the various ways. Generally, what happens in homogeneous reaction systemization, you define the rate of reaction only in terms of 1 upon V dNA by dt, that is concentration per unit time, that is equals to the rate of reaction or rate of change of concentration per unit time. Are you saying? But in case of heterogeneous reaction system, in case of heterogeneous reaction system, it can be defined as different way. So first way of defining rate of reaction over here is, just to wait 1 second. Uh, so first I will be defined based on the volume of reacting fluid. Okay. Based on the volume of reacting fluid and measurement, it can be defined in this way, that is equals to minus of Ra, okay, that is equals to minus of Ra, that is equal to minus 1 upon V, that will work as a dN upon dt. That is homogeneous reaction system. Like already this looks like a homogeneous reaction system. Second is based on unit mass of solid. So here you can define minus of Ra dash, that is equal to 1 upon W, and it will be equal to dNA upon dt. Only this particular change things will is gonna be changed. That is here was it was volume, it was per unit mass, and third is based on unit interfacial area. Interfacial surface area, you can like surface area in two fluid system. Okay, so you can write minus of Ra double dash, that is equal to minus 1 upon SS, and it is equal to dNA by dt. Okay, so these three things, one is 1 upon V dN by dt, one is 1 upon W dN by dt, and next is interfacial surface area minus 1 upon S SS dN by dt. And next one and last thing that has been left for this particular rate of reaction, and that is equal to 4, and that is based on unit volume of solid. Okay, so based on unit volume of solid, you can write my direction minus Ra, that is equal to minus 1 upon V and dN by dt, like this. Okay, so all these rate of reaction becomes very important when we talk about the heterogeneous reaction part. Okay, so now coming to some theoretical concept in this particular topic, and that is gas solid catalytic reaction, that is basics of this particular topic. Gas. One of the best example for this particular model you can understand, that is the burning of the coal. Coal is burning, that is coal is a soluble work as a solid bed, and it is burning in presence of oxygen. So the reaction there that is occurring over there, that will be called as the gas solid reaction. Okay. So now try to understand how this reaction takes place. So just like it is solid, I am assuming. Okay. And what happens over here, my dear friend? So the concentration at the solid surface will be equals to what? Ci. And here, if it is gaseous system, then here concentration will be Ca gas. Can I assume? So this gas will come and get react with this particular solid. So it will, I am assuming this is non-porous right now. Non-porous. Okay. We'll let you know how porosity will affect the rate of reaction and all. But here, try to understand without, uh, so what happens at a steady state? It is solid. It's not porous. Okay. That's why I'm making in this way. A steady state, what happens? A rate of mass transfer, that is equals to rate of reaction. The mass transfer is only possible due to the rate of reaction only over here. That's why at a steady state, what happens, my dear student? The rate of mass transfer, that will be equals to the rate of reaction. Are you getting? Hope up to this everything is clear now. So here I am writing. Okay. So can I write a rate of mass transfer, and that is equals to my distance Km, and it is equal to Ca gaseous minus Cai, that is concentration difference multiplied with mass transfer coefficient, and rate of reaction, that is equals to Kr into Ci. Are you getting? It is, this concentration is Ci, this concentration is Ca gaseous. Are you getting? So rate of mass transfer, that is equals to rate of reaction I have written. So can I write Km Cag minus Cai, that is equal to Kr Ci. Think up to this everything is clear. Okay. Next, can I write here? We have to calculate the concentration Ci. So can I write my distance here? Km Ca gaseous minus Km Cai, that is equal to KRCI. So CAI will get common. So can I write CAI? So Km plus Kr, and that is equal to Km CAG. So can I write here CAI, that is equal to Km CAG upon Km plus Kr. Are you getting? So you will reach up to this conclusion. Again, can I write my result? Minus of the rate of reaction, that is equals to Kr Cai. So can I write minus of R, rate of reaction, Kr that you have to Ci we have calculated, that is Kr, and we have calculated Cai, Km Ca gaseous upon Km plus Kr. So minus of R by R of R, that is equals to Ca gaseous upon, can I write Km plus Kr upon Km Kr. Anyone has any doubt? So can I write minus of R, that is equals to Ca gaseous upon 1 upon Kr plus 1 upon Km. And it's a very important thing that you have to understand over here. If my distance Kr is very greater than Km, I mean rate constant is very greater than mass transfer coefficient. Kr is, just wait 1 second. Here I am writing Kr rate constant and Km mass transfer coefficient. So here first I am assuming if Ki is very greater than Km, you can write 1 upon Kr is very less than 1 upon Km. Are you getting? So 1 upon Km, that will be tending to 0. So minus of rate of reaction, that is equals to Cag upon 1 upon Kr. So that is equals to my resistance Kr into Cag. Here rate of reaction will dominate. Okay. Rate of reaction will dominate. That's why you will get the equation like this. First thing. Second thing is medicine. Second is if uh, if Km, here Kr is greater than, here it you can assume Km is very greater than Kr. So 1 upon Km is very less than 1 upon Kr. So 1 upon Kr tending to 0. So can I write minus rate of reaction, that is equals to my resistance Cag upon 1 upon Km plus 1 upon Kr. As above discussion, it is equals to 0. So can I write minus of R by R, that is equals to my resistance Km and Cag. So you will see these two terms at different conditions. So here what happens in this particular condition, my dear friend, you can see, I'm letting you to understand one more thing. You can say this thing is overall resistance. So here you can write mass transfer does not affect rate of reaction. I mean here it is kinetically controlled. It is kinetically controlled only, and here it is mass transfer control. So up to this above discussion, I hope I have tried my best to let you understand the thing how heterogeneous catalytic reactions we can define, and there are different ways to define the rate of reaction in heterogeneous solid gas catalytic reaction system. And after that, I have come to let you know about the mass control region and the kinetically control condition of gas solid catalytic reaction. Now, from the next lecture onwards, I will be discussing about the diffusion and reaction within solid cylindrical pore catalytic catalyst and solid spherical pore catalyst. That's very important for my dear student for the gate point of view, and we'll define about the intrinsic rate of reactions and all different parameters. Okay, so hope I have tried my best to let you understand the concept. If you're facing any doubt, you just go to the video and try to solve number of questions on this particular topic, and at the end of the completion of this particular topic, we'll discuss some numerical problem also that has been asked in the gate as well as in the back also. So from there you will get some good insight about this particular topic. Okay, so thank you all for watching this video.